This is a critical video dealing with the point-slope formula, but before we get into how to use the point-slope formula, I want to review with you the three forms of a line that we have so far. The first one, where the x's and y's are on the left and there's a constant on the right, is known as the standard form of a line. This second one, y equals mx plus b, is, as you know, the slope-intercept form of a line. And the third one here is the new one, which I'm teaching you right now, which is known as the point-slope form of a line. Point-slope. Okay, each of these have their uses. The standard form, I'm going to say, is useful for graphing by intercepts. And to remind you of that, I'm going to just draw a quickie little sketch here of an XY chart with 0 as the input for x and then 0 as the input for y. Now, the second form, the slope-intercept form, you know it's very useful for graphing. But it's also very useful when you're trying to identify the slope or the y-intercept. So useful for identifying the slope and y-intercept. Now this third formula here, the point-slope formula, I'm going to say it's useful for finding the equation of a line given clues. Sometimes we don't just give you the slope and the y-intercept directly. Sometimes you've got to play along with some clues to find the equation of the line. So what we're about to have on this sheet of paper is 5 different problems representing 5 different patterns, and the overall direction is find the equation of the line in slope-intercept form having these characteristics. Now in problem A, this is about as easy as you can get because we give you the y-intercept. So if you're looking for y equals mx plus b, the m was given to us, so y equals 2/3 x, and the b equals 5 was given to you, so you can just go straight to your solution there. Now that's a very specific pattern. In problem B, again you're given the slope, but this time you're told not what the y-intercept is, but just any old generic point. This is a point and a slope, and this fits this new formula perfectly. That'll be our x1, y1. I'm going to use this formula, y minus y1 equals m times x minus x1, and substitute in the numbers. Y minus y1 will become y minus 4 equals m, that's our negative 3/5 that we were given, times x minus a negative 1, which becomes x plus 1. Now all we need to do is distribute. That gives us y minus 4 equals negative 3/5 x minus 3/5. And then we want to isolate the y, and that would mean add 4 to both sides. Now that's really a 4 over 1, and we'd rather it be something over 5. So if one denominator is 5 times the other, the numerator is 5 times the other, and we're adding 20/5, and that's going to give us y equals negative 3/5 x plus 17/5. Notice all we had to do was substitute in the given values to go straight to our equation. Now I'm going to show you another method here. It's not the method I'm going to continue using, but I at least want to show it to you. Some people will prefer to start with y equals mx plus b and then substitute in the m, the negative 3/5 x, and then look for the b after that as a second step. Now the logic here would be, since this point is on the line, the point works in the line, and you can substitute in the negative 1, 4 for x and y. So you can have 4 equals negative 3/5 times the x, which is negative 1, plus b. Do some multiplication here. 4 equals 3/5 plus b, and then subtract the 3/5 off, and we've already done it over here at the left. You know that you're going to get 17/5. Then you can reassemble your equation and say, I've got my m of negative 3/5. I now have my b of 17, and I can then go and create that formula on the left. It works perfectly fine. It will work every time. However, that was a two-step process. First, identify the slope, then solve for the b, and then put the two together. Whereas what we have on the left goes directly to your formula in one step. So this is the pattern where you're given a point and a slope.